Yeah, we're live. It's 6:55. Decided to be a little early today because, what the heck? I've been late every other day. But today we're talking about, I'm just getting this picture up for myself so I can take a look at it and refer to it. Today we're talking about the thumbnail is a 4.6 liter 3-valve motor. So, ostensibly the motor before they started introducing Coyote. It was a good step up in performance, obviously, from the 2-valve and was making as much power as the 4-valve. And so we all wondered, why would you go that direction? But the variable cam was nice. The intake manifold was a really good design. That didn't stop me from making, as you see here, a very custom intake manifold. And not only was it custom because it was dual plenum and the plenums were attached or not attached, depending on how we wanted to run it, but it was also adjustable. So you can see in the photo that I have the lengths of aluminum tubing, which I think that those are probably 2-inch. They have flares and slip fits. Just allows me to, this was how simple it was to make this and adjust it and find out what works and what doesn't work, kind of where the runner length wanted to be. And not just where it wanted to be, because that's assuming that you find something that's like ideal for every situation. You don't. You'll find different things. You'll find shorter ones that work better up top and longer ones that work better down below. And so ultimately, you're going to have to choose, just like we do with camshafts and everything else, unless we have a variable runner intake or an infinitely variable runner intake or an infinitely variable cam timing. So there's going to be some kind of trade-off there for for most normal situations. The other thing that's there is, if you take a look at it, you'll see how simple it really was to do. We cut the bottom off of a factory 3-valve intake manifold because it already had the provisions for our injectors. It already had the mount for the injector. All we had to do was open it up to our desired size. We took our 2-inch tube, which is about the right size for the opening in the cylinder head, and gave us room to go bigger. We just squinched down we honestly just squeezed it with in a vise and pinched the end down to take the round tubing to the oval transition, because that's what shape the head opening is. All of this was very easily done, and it made it nice. And this was the preliminary design that I used to determine where this thing wanted to be. Was there a way that I could improve upon the factory intake manifold? And as that turned out, there was. And I made a version of this. I made a version that actually ran and fit under the hood and drove around. And we ran it NA and we ran it supercharged, and we drove around in a vehicle for quite a long time, for several months. And it worked very well. And then I took it apart because I was trying to make it better. And then I never put it back together. So there was one of one, and then it got taken apart. But this adjustable version, I still have. I have most of it. Obviously, I have all the slip fit tubing. We have the plenums. I don't know if we use the flanges for something else. I'd have to go back and look. This was a long time ago. But there are a number of interesting things. One is that, like I said, we have a slip fit tubing so that we can extend it, and then you just make different lengths of aluminum tubing. Just cut them to the, have a 1-inch, a 2-inch, a 4-inch. And when I say have that, you have 8 of those so that you can do it to all the cylinders. And 1-inch, 2-inch, 4-inch, 6-inch, 8-inch, whatever, however long you want to make it. We made this thing fairly high. I think we probably put, 15 or 20 inches of runner length in it, and then stack it up. We had 2 plenums. The plenums were shared with the other modular Ford because the bore spacing was the same. So where the intake center line and the ports were, they kind of shared that enough that we could get by with doing them all with these same common plenums. We had 2 75mm throttle bodies on there, dual 75s, enough to feed lots and lots of power. We also had, in the back of the plenum, we had openings, basically. So we had dual openings, one in the front and one back. The ones in the back were designed to allow me to either connect or not connect the plenum so that you can change the resonating volume. The resonating volume basically was half of one for each of the 4 cylinders, or a combined one for each cylinder. And that made a difference in power. The other thing that's interesting, and the thing that I want to talk about most tonight, is if you look very closely in the photo, you'll see that there are actually injectors. We put injector bungs on the top of the plenum, right above, hopefully if we did our homework and applied it correctly, right above each one of the ports. So the question for you, and that's going to be our poll for tonight. With the injector poo, the injector position in the plenum above each cylinder provide adequate fuel distribution. So that's going to be our poll question for tonight. With the injector position, you can see in the photo, with the injector position in the plenum above each one of the ports, and you have it separated basically by the amount of the plenum, would that injector position, because we know that changing injector position can improve power. We've seen that a lot. The farther away it is from the valve, it has more time for charge cooling. We see that in carbureted applications and stuff as compared to port injection and stuff. But would that injector position provide for adequate air fuel distributions? Because it's got to spray, down the plenum and then into the port. Would that work? And I only said adequate rather than perfect or best. Give us a little bit of leeway there. So that will be our question for tonight. So what do you guys think? What do you guys think about would that be a distribution problem? I mean, all that air is rushing in, and it's just going to grab all the fuel and pull it to the back cylinder, right? The other thing I should mention, if you look inside each one of these plenums, they're not a radius entry on the floor of the plenum. They have a standoff going into the runner. So they have a standoff and a full radius air horn for each cylinder, both to improve airflow and the radius air horn is to improve airflow into each one of the ports. Also, it changes the runner length, which changes the initiation of the reflected wave, and also takes away some of the plenum volume. And in our case, also gives a bigger target, as it were, for the injector spraying into there. So some of the questions I'm hoping that I get tonight is, well, Richard, what kind of injector are you using? Are you using a 20-degree cone? Are you using a 0-degree cone? Is just like a pencil type injector? That's what I call it, just a straight squirt right down the port. Is it a 50-degree cone? So most of it's just missing our radius air horn anyway. Does that even matter? Because like when we see a carburetor on top of a manifold, like a single plate manifold, it's not anywhere near the port and not directing its fuel exactly at a port like we're spraying the injector at. And yet it still works because each one of those cylinders grabs an amount of air and fuel, and hopefully, ideally, it would grab the same amount of air and fuel for each one of those. It doesn't, because none of the runners are the same. or all, I should say, all of them aren't the same, because some of them might be the same. Some of them might flow the same and have the same basic length and taper and design. Although I've never sectioned a dual plane intake manifold. We know the single plane could be close with the 4 longs and the 4 shorts. It could be that 2 of them or 4 of them are similar. Dual plane, that's going to be a little bit harder, but I would be interested to see if that's actually the case. In that case, then you would think that they would be, grabbing the same amount of air and fuel. But in this case, we would be injecting it through the plenum, perpendicular to the airflow. Whereas opposed to a carbureted deal, the fuel and air would be going in the same direction. Does that affect it? Has anybody ever looked at the old Formula One plenums from back in the original turbo era way back, and saw what they were doing with their little 1.5 liter mega boosted Formula One motors? It's good stuff. So let's see what you guys got going on. So that's my spiel for tonight. This was a cool intake, and like I said, I first used it on a 2-valve, and then a 4-valve, and then the 3-valve, and then the earlier 4-valve. I did some testing on that as well to see if we could, because we ran on the early 4-valve. You would think that one would have had more development time than the later 4-valve. But that B-headed deal, we tried a few of these different double throwdown intake manifolds, and none of them seem to work that great. Mahovitz has one that he ran, which was a sheet metal tunnel ram style bottom feed. I think I remember one of his was done by Hogan originally, but it was so modified that after they were doing distribution tests, obviously you want in a super high horsepower motor, you know that you can deliver the same amount of fuel to that, but can you get an equal amount of air, especially when you're running 30, 40, 50 pounds of boost, whatever John ended up doing with that. I know that it was a lot. So at that point, distribution would kind of become critical. But so he did a lot of work on the intake manifold to try to get it to do that. So let's see what you guys got going on. 1 Liter Mafia is in the house. Personally, I blame John Woodward. Love hearing about the custom intake manifolds. It is fun. And I have one like this for the Atlas already done as well. On the street, is it really worth going to Beehive Springs versus dual springs with a damper? Motor will hardly see 5,500. Are you? Which one are you not wanting to put on? The Beehive thing isn't mandatory, nor is a dual spring. The spring kit that you would use is going to be based on the camshaft. Richard, have you ever tested the Holley Sniper EFI system that has a nitrous controller built in? Is that we can run nitrous with our Holley HP? So yes, but not a Sniper one. Richard, I think my summer project before I return to college after a 2-year hiatus is going to be building an IH392. That's good. Lighter pistons and rods, valve springs, cam headers, and porting 400 horsepower. That I don't know what the heads flow on it, but 392 inches and 400 horsepower is just right near the 1 horsepower per cubic inch deal. So that's a really kind of mild combination. So that should certainly be possible. You're talking about having a cylinder head that just needs to flow more than 200 CFM. And then if you make it a 9-to-1 or a 10-to-1 motor and put like a 224 camshaft in it and a dual plane intake with a 750 on it, 650 would probably also work. That should work out okay. Corey, you're sitting in your basement porting your 3-valve heads. We did a test on 3-valve heads way back, and they didn't really show much of a gain. But like I said, we weren't running this thing with the variable cam timing, which I think we should have. And we had stock cams in it that we weren't controlling. So I don't think it was a good test. The head certainly flowed more. So that tells me that we just weren't taking advantage of it. The 392 has a 4125 bore, so it's a short stroke motor. So it's going to love to rev then, right? It's going to have a good rod ratio. I'm on Jag site trying not to spend money. Injectors high in the trumpet is some Formula One stuff. Yes, that's where all this comes from. If you can get a 392 head to flow 280, you'll have trouble only making 400 horsepower. It would be more adequate to have the injectors higher facing reverse to help disperse and cool charge temperature. Well, we can't have them any higher than if maybe you haven't looked at the photo. But the photo is to put them higher, they would be up in air away from the intake manifold. So they can't go up anymore. Formula One did turn them way back. They don't do that anymore. But that was another thing. Like to do a Dodge 440 Big Bang. Have you seen the Maribera that Steve Morse is building? I did. I saw I watch his stuff, so I saw the bottom end girdle that he did, the main girdle thing, is pretty cool. Richard, if you're working with commercial, I'm not working with commercial motors. This was a 463 valve that we had way back. Did some nitro testing on a GSR engine with Kinsler injection. The fuel was sprayed directly straight down the hats with good results. Yeah, you're spraying it into the port, right? I think he was talking about spraying it up against the direction of airflow, which is what Formula One did for a while. I don't think that they still do that, though. And having, if you're running, nitromethane. Yeah, or methanol, also very good for cooling. So you think a Dodge 440 on a Big Bang, you think that the mains would be the problem before a rod or a piston would be a limiting factor? Is the bank fire fuel injection or a sequential fuel injection for the poll question? That actually doesn't matter for what we're doing. Richard, I ran into an issue today measuring push rod length on an LS with mass black label heads on it. Mass heads have their different rocker stands. Yep. And also mass, the rocker, where the rocker stand mounts is different than a stock one. So it's up higher. Much thicker than stock. Yes, all the mass heads I've run have required a longer push rod. What's your favorite cam for a stock bottom end 94 351? I have ported first gen wedge heads. My turbo setup are street driven. Well, there's two choices for the bigger motor. The 274 cam is a really good one for driving around. And honestly, with good heads and that cam on a 351 and a turbo, you can make, a bajillion horsepower. If you want to make more NA power, you can put that 236 XFI camshaft in it, although it's not going to drive as well because it is quite a bit bigger. It's 236, 248, so it'd make a lot of NA power. I think with the turbo, I would just go with the smaller one. Mike's back in the house. Your 8.1 is running, making 70 pounds of oil pressure, winning. So you got the stock camshaft back in it. Nice. I don't think I did. I never got a ride in that truck, right? The 8.1 with he's got a turbo 8.1 that he's been driving around forever. So it shows you that it doesn't just work on the dyno; it also works in real life. Injector placement on a 3.1 MPFI GM motor would inject fuel onto the back of the intake valve. That's not unusual for that to happen. The 3.1 SFI would angle injector to spray fuel past the valve directly into the chamber. And there's a difference in power, but my guess is that's not the only change. I'll bet that there's another change. Where they spray the fuel can't be 20 horsepower on that motor. I would almost bet. Eric's here. I'm just scraping the wood grain off my Grand Wagoneer front fenders. Looking to put LS6 valve springs onto an L67. Do I need standard retainers or aftermarket ones? We used aftermarket ones. I'm thinking that stock ones would also work. Because I think that the valve is the same. The keeper arrangement is the same. And the valve stem diameter is the same. So I'm thinking that the retainer would be the same. I can't remember now. I went through all of that to measure if there was a change in installed height from putting the other retainer on and stuff. But I don't have my notes in front of me. Local paper sale, 91 Geo Metro, good solid car, good body, not driven lately, new tires, 875. I wonder if not driven lately equates to it ran when it was parked years ago and now it's just not going to work. Those are good. Especially if it's an XFI. I like the high mileage ones, and then of course the Sprint Turbo is kind of that, but a Chevy version and a turbo version, which the Metro is not. I have dual springs on my heads already. I went with a smaller cam due to economy and says it can use a beehive or dual spring is slightly less in pressure. I was told a little more is okay. Yeah, you're fine. If you've got springs on it already and you change down in cam size, it will work fine. We're at the zoo. I heard seals. No, that's Milo. That's my golden retriever. He's on guard duty. Somebody came to the front door. It turned out it was my wife, but he's still, he barks first, then asks questions later. What kind of cam duration would you run in a 408 with an 88 millimeter turbo? That would depend on how much of the 88 millimeter turbo you're going to use. Are you wanting to max the turbo out? Are you wanting to make, I don't know which 88 it is, but let's say it's 1500 horsepower with a turbo. Is that what you want? Then I would try to make more power out of the 408. For the 408, I would put that 248 XFI camshaft in there. I hope that it has good heads on it and stuff too. If you look at the video that I have up on the 408, we ran that, and then we ran an even bigger camshaft on it that made over 600 horsepower. It had good heads and a good intake manifold on it, and was, I want to say that it was in the compression was in the 10s or so. The second cam that we ran would be what I would put on if it was an NA motor and I didn't care about driving it around. With an 88 millimeter turbo, you're not looking for street response anyways. Thanks for the advice, Richard. Well, I look into it. Chad, we don't use the word thoughts here. So if you're asking a question, just in the future, don't use that. But you don't need a stage 4 L83 cam. You should put a stage 1 in it. Stage 4 is going to require valve release. Let me know when you're in town. I'll be down in Southern California tomorrow. So he made Jonathan, he made a 447 stroker, 550 horsepower and 610 foot-pounds. That's a lot. But the heads have flow to support that kind of stuff. Why wouldn't it make a difference in bank fire or sequential? It wouldn't make a difference for, I don't think it would make a difference for what we're talking about. Is the fuel, if you spray it from where it is, basically the question is the fuel going to go into the port? And you think it would make a difference whether it's a batch fire or sequential as to whether the fuel is going to get where it's aimed into the port? The 3.1 SFI had better heads in a plenum, but had intake gasket issues. Yeah, I would think that there would have to be something else that where they're spraying it. When they make changes like that, it's almost never for power. It's almost always for emissions or drivability or fuel mileage. Ran when parked, now needs to work to run. But it might be an easy thing. Like you said, you just taking the plugs out, spinning it over, put some fuel in it. Mike, you've got 590,000 miles. That's nice. Are the AFR 195 race cylinder heads for small block Chevy worth the additional money over the 195 Enforcers? Almost triple the price. They are if what you're trying to do is max out what each one of those heads will do. If you just have a street motor, I wouldn't do that. Because it might be on a street motor, you're not even taking advantage of everything that the smaller one or the regular 195 has. An 88 millimeter turbo is only useful if the 408 has enough cam to make power at 7,500. Why does the turbo care where you make peak power at? Project 23 is back with more ideas on the 300. 300 LS. I do kind of want to do that now. After Jimmy and I were talking about that. High voltage. My main question was, in your experience with mast heads and rocker stands, how much longer of a rocker bolt do you use? Well, you want to have, I can't give you a dimension because I don't remember that off the top of my head. But when you put your rocker bolt in, don't put it in with so that it's pushing the spring down. First of all, you don't want to load it like that. That's a good way to have it pull out. But to test it, just put the rocker on without the push rod in. And then what you want to do is, this is easier to do on the intake normally, although on the masthead it might not do that, because the rocker bolt usually goes for the rocker stand usually goes all the way through into the intake port. You want full engagement of all of the threads. The more thread engagement that you have on that, the less chance you have of stripping it out. If you're only grabbing a few threads, it's definitely going to pull out if you try to torque it. Just measure the depth of the hole and then measure the depth of how far past the rocker stand your bolt goes and subtract the two. And you're like, oh yeah, I'm only, and then also a lot of those bolts have little nubs on them, a guide nub basically. And that's not thread engagement. So that's not part of the length. You're only measuring the thread length. Would a 276, 278 stage 2 or 265, 275 stage 3 cam suit an L67 with a 14 PSI pulley? Why is the stage 3 cam smaller than the stage 2 cam? Is there any other engine that can be safely offset ground to increase 50 cubic inches other than the 392? I don't know. I've never taken measurements on any of that. What's your motor oil of choice? Mine is whatever's on sale. The new stage 4 truck cam, they say, will do 500 with bolt-ons and no fly cutting. I haven't seen that camshaft then. And you'd be better off talking to Brian or to the guys at Brian Tilley Racing about it. I haven't tested that. I think Brian sent me information on the L83, but I didn't remember whether a stage 4 was part of that or not. Single-cylinder engines tend to spit a little fuel out from the carb, but subsequently suck it back. The plenum flow from front to back could rob that fuel from the front runners. I didn't see that when we had the injectors above the IR setup, but we didn't have a common plenum on that. Is more duration better than more lift? Why do you have to choose one or the other? More duration will make more of a difference in the power curve than more lift will. Whichever one of the L67 cams makes more power NA, that's the one that will work best under boost. Would running injectors at 100% duty fill the plenum similar to a carb? There is going to be fuel in there, obviously spraying across there, but I don't know why it would happen at 100% duty and not other duty cycles. Project, you need to rephrase your question. What position of injectors in the intake manifold gives you more charge cooling? The farther away it is from the valve, the better the cooling is. Adrian, remember, this shouldn't be stressful. This should be fun. So you should get in the right spirit. How's our poll doing? Our controversial poll doing? 76% are saying yes, that the injector position in the plenum above each cylinder will provide adequate fuel distribution, that there won't be like, all the fuel's not going to go down and like, exit stage left or right, whichever. That's probably right? Yeah. Squirrels in the house. See, Larry, you're here where we already had a poll before you even got here, right? Everybody answered it and then left because they weren't even going to wait for you. I can't wait to do the testing on the Atlas motor with that adjustable intake manifold, especially with cams. Is that a boosted intake manifold? Why, yes. Yes, it is. Richard, have you tested collector secondary length on a Ford 4.6? My understanding is that the vacuum scavenges the intake charge into the cylinder faster. The collector extension after the merge of the 4 tubes, we have tested that on all internal combustion engines, and that has an effect on power. You can spray fuel at the air filter for maximum distribution. Yes, that would be good. You should try that. One of the Atlases will definitely get a big bang because I have 2 of them. Yeah, Mike, they've tried injectors in a bunch of different positions, and you can do that. And as soon as somebody goes and reads an old Formula One book, oh, that like this is top secret science. Look, they're doing this, so we should try that. Yes, you should. Richard, you should come visit us here in Carolina. HED is based here in Mooresville, along with Customs by Biggin. Cletus went personal best with Pete's tuning. That's cool. Yeah, he went fast. With see-through panels in the plenum, high-speed camera, and oxygen sensors in every tube tell us a definite answer of what? Of whether the ports are getting fuel. Yeah, it'd be cool. It'd be really cool to see with a strobe. The airflow increases. It applies fuel like normal, just a very minute amount, like water meth or something like that. Okay, let's see. So this is your other question. So I take a normal port sequential injection and run a fully polished plenum for carb use. I don't know about why the polish is there, but I run a total of 2 feet from the port to the 2 feet. You're running 24 inches from the ports to the carb, and have that behave as both a throttle body, but also as the vacuum drops. So it sounds to me like you're just making a really long runner carbureted intake. But you're getting your fuel through the port injection. Is that what you're trying to do? and trying to get charge cooling through the carburetor. We've tried getting the charge cooling through a carburetor, or I think that when they were trying to do it, they were trying to do it through one of those 4-hole throttle bodies, and then also have port injection so that you could get equal distribution and get charge cooling. And it didn't work out as nice as I was hoping that it was going to. I wasn't part of that test. That was the guys at West Tech, but got double the votes now. Nice. Like to see windows in the plenum. It would be cool, and would be cool to have a strobe. I remember one of the nitrous guys that was trying to set this production stock bodied Camaro Firebird thing out at Bonneville. He had a big open plenum like that was lucite or clear or something, and they're running it on the dyno at West Tech, and he ran a bunch of nitrous on it. I remember what chaos there is inside there with the nitrous. The interview with Walt Ware of Garrett Air Research is pretty interesting. He even worked on the SR-71. Cool. Yeah, Gail Banks does good stuff, and he knows a lot of guys. He knows a guy. Have you ever dynoed poorly or overported heads with cams? We have run heads that don't run nearly as well. Like some of the Speedmaster stuff, or this was Pro Comp, I think, back in the day. Some of those, the big block heads in particular, were really, really big, and they actually had a decent amount of like peak flow, but they didn't really make very good power. And then the same thing with some of the Ford and Chevy small block stuff, that they seem to be ported, but not very effectively. And we obviously ran them with cams. Hot rodding is all about trial and error. And that's one thing that a lot of people don't realize is that I get this, like when I go down a path toward, okay, I'm going to put a Barra on there. I'm put a Mare Barra on there. I'm going to put a Geo Metro motor on there. And they're like, oh no, you need to go see this guy. He's already done this. I'm like, that's great. Except that I don't want to do what somebody else has done. I want to do what I'm going to do. And even if it ends up duplicating what somebody else already did, I still got to do it. It was still fun. It was still cool for me. And the people that are going to watch what I'm doing are probably different than the people that watch what he's doing. Or the other thing that people don't realize is that people that watch whatever they did, if it was a Dodge Turbo 2.2, if they watch that, they're going to watch this too. If you're a Dodge 2.2 guy, there's not enough stuff out there for you. So you're going to watch both. So I'm not worried about that. And like I said, I want to do it. I know that there's guys that have built. Morris is doing a Barra with a crazy like main girdle stuff. He's done LS motors. He's done big blocks. He's done all of it. That doesn't mean that we all shouldn't be doing it too, though. Timmy's trapped in the well. We had two collies for a really long time. And so that always it was, Timmy's trapped in the well because, they're collies. I'm thinking of chopping up Ford 6.2 single overhead cam heads to work on the 300 since the bore spacing matches. How well do you... Ford 6.2 bore spacing is the same as an LS? Because that's the same as a 6-liter, right? The valve size doesn't interest me at all. The head flow would. And does that single overhead cam head flow like an LS head does, or like a Boss head does? On a 393 Windsor, is the air gap worth the expense over a performer intake? Yes. Project 23, I don't know. Let's see. Along with the massively improved airflow and way better port angle of the single overhead cam motor. Well, you should do it then, man. Daniel, let's see. This is Larry running my streaming computer. Nice. We like to hear that. That's what everybody should do. So I have a couple people that just leave their computer on and have it on my channel and just let it run all night. So everybody should do that. That's the advice I'm giving to people. It should just be streaming nonstop in your shop, at your house, on your mobile. For the pole answer, I think it would be okay for tests on the dyno, but at the drag sip, it would run the front cylinders lean and the rear cylinders rich. So are you assuming that the intake is sticking up in airflow or something? What if all of that's under the hood? You think that the acceleration is going to do that, or airflow is going to be different than it is on the dyno or something? I'm just curious. You know, inquiring minds want to know. The single overhead cam head ported at 750 lifts, flows 318, 294. If you want to add a little something to a 5K walk and run, take a 12 kilo kettlebell for a 5K run. That'd be a lot. I have a vest that we wear that's it's amazing how much, and it's only, I don't know what it is, 10 or 20 pounds or something like that. But it's amazing how much of a difference that makes. If you had to walk, like, oh man, if I was this much heavier, this would not be fun to walk around like this. Yeah, Ark, if you turn it on and leave it on at night, you'll sleep learn. It's guaranteed performance. Are the Speedmaster Pontiac heads any good? I don't know. I'm going to let you know because we are going to run them. Richard, what do you think about Speedmaster Smallbuck Ford blocks? I've used 2 of them now, I think. And both of the ones that I've used have worked fine for us. We took them in and had them machined properly. The weird thing about them is that they have some of the hardware was weird. The threads were standard and the bolt head was metric. So it was odd. And not just metric like, oh, I can fit a 13 on a half or whatever. They were metric. The acceleration affects the fuel in the plenum, same as it does with the carb setup on a tunnel ram. I could see how acceleration would affect fuel in the bowl. It would have slosh. I'll take a backpack along with 15 pounds in it, plus a kettlebell. That's good. You must be in good shape. How's our poll doing? 74% are saying yes, that they think that the situation would work. Turban Research, thank you very much. Your knees will notice. These hips don't lie. Your ankles and your hips. The math you mentioned for fuel injector selection was the flow rate times 16 for a V8. And for E85, you need to multiply that number by first by 0.85 and then 0.75. Once up to speed, it has no effect. Yeah, you're just talking about the acceleration and it moving the fuel column. I understand that. I'd like to see that in, because it would be cool to see the fuel spray bend under acceleration. Once up to speed. Okay, let's see. Building a 462 rocket block, small block. 8 single carbs have a short distance from the head. How is the air-fuel mixture measured per cylinder versus port? Where do you have 8 carburetors? Asymmetrical turbos or symmetrical turbos would be good. Oh, wait, here we go. Turbo research. I forgot to read your question. I'm back. Let's see. Have you ever tested an asymmetrical turbo setup? Would you ever entertain an asymmetrical turbo setup for one of your future tests? So what do you mean by asymmetrical? Do you mean that one turbo is different size than the other and we're running twins on it? So let me get back down to where you're explaining yourself here. Diet and movement are really good for changing. I want to run E85 in my Holly, but I can't find any DIY guides anywhere. In your Holly carburetor? Have you ever done anything with the V10s? I have not. The Nelson makes symmetrical turbos. Is there a mathematical formula? Yes, there is. It's very complex, though. But is there a mathematical formula for intake runner length and where torque peak torque occurs? Yes, there is. Like I said, but it's beyond me. I don't ever use it. That's why I make adjustable intake manifolds. It's a lot easier to see. Do you know what starter? A stock starter will work fine on a turbo 5.3 because you're not gonna, if it's a turbo one, you're not gonna be having high compression. It's not gonna be hard starting. So the starter will start a turbo 5.3 the same way it will a stock 5.3. The dampener, most guys use the factory one. It's not a balancer though; it's just a dampener on an LS because it's neutral balance. And if you're running more RPM and you want to put something nice on there, you could go with ATI. 2 different size turbos for each side. So we want to run like a GT35 on one side and GT45 on the other side. Is that what this was? And let's see, 1 turbo on a V8 with only 1 bank of the engine feeding the turbo, and the other bank with a long tube header, both banks fed by the turbo. Oh, so you want to just do a single turbo, but fed by one side of the motor. I have already tried that once. I did that on a big block, or I tried it on a big block and it didn't work. But I know that it can, and I do want to revisit it because it just didn't work on the big block that we were trying it on. But I did try to do that on it. In fact, it was on the motor that we were setting up to do the Big Bang big block. I ran that with just a header on one side and then the turbo exhaust feeding the other side, just feeding a single turbo. And I think we even went down in turbo size to try to do it. I can look here and see. In fact, I can try to see if I have the information on what turbo it was. I think that I do. I was disappointed that it didn't work because I just wanted it to be like the Saab stuff. So we'll go to big block Chevy. We'll go to turbo. Gen 5 turbo carbureted. I don't think that that's it. Big Bang Junkyard Base. Nope, that's probably not it. The Demon, EFI. Yeah, I'll have to try to search around and see where the information is. I know it's up there. I'll have to go through a bunch of runs because I don't know if I labeled it properly because I never used it as one of the finals. So I label everything that's going to be something that I use as a final. And because it didn't work, I never labeled it as such. It just was another experiment that I tried on the dyno that failed and didn't make. I think we only made like a pound. And I even had Ish come over. I'm like, is there something I'm missing here? He's like, well, let's try more timing. Let's try less timing. Let's try all these things. I tried two-stepping it, whatever. But it just would never make any boost. And so I do want to try it again. Let's see here. I'm finishing up my 300 horsepower, $800 budget 300 after you're going to bore it 425 and have the crank re-welded to give you 351 inches. Bob, this is a good observation. I like this kind of thinking. Seems that under acceleration, a 4-cylinder front-wheel drive with the intake in front of the engine should make more power than one behind because it should be pulling that air away, right? Or pushing it forward. Don't run E85 on a carb turbo engine. Why is that? I did exactly that. I ran E85 on a 4412 500 CFM 2-barrel on the inline 6-cylinder. What kind of power do you think an LSX 376? What kind of power do they make when they're NA, when they're stock? They don't make very much. Isn't the formula in the S8 combustion engine fundamentals book? It is, but like I said, most people I think will not be able to figure out. They won't be able to determine an RPM like they want. Like they want it to say 14 inches. It's going to occur at 3,800 RPM. They're not going to get that from the formula. What do you think about locking the DIS? Are you talking about distributor? On another subject, I used to run NASA Arizona 2.3 MZR and a 2002 Ranger. I had issues with dual Weber DCOEs. Did you had side drafts on it? Unless I ran them 6 inches from the port. If I ran SEFI, I could have had the plenum closer. I'm not really understanding what your question is. So you had a problem with side drafts on a 4-cylinder 2.3 liter, and they had to be 6 inches from the port. So the total runner length had to be 6 inches. That seems like a lot. I mean, none of the Canon manifolds and stuff I don't think that they're that long on the Z's. You should be able to run the carburetor like basically on the head port, and it should still work. You should also be able to put stack length in front of the carburetor and have that work. I don't know why does the Weber it shouldn't have a common plenum, right? Those are going to be side drafts. Saab and some old Toyota racing Indy cars use asymmetrical turbocharging, like you mentioned. It just made me curious as what would make it better than both feeding the turbo. Saab was trying to do it for fuel mileage, I think, why they were doing it. And the other guys that I saw try this were the Cadillac team that they didn't run asymmetrical turbocharging. I guess they kind of did. They had a V8, but only ran 6 of the cylinders to feed the turbo, and the other 2 didn't. And I think what they were trying to do was trying to improve fuel mileage, maybe. But we were scratching our head on this because we're like, well, the motor, when the fuel goes into or when the air boost goes into the port, unless the boost wasn't going into those ports, unless those 2 were naturally aspirated somehow, and that the other ones were boosted. If they were all boosted, they're all going to go through have the same amount of fuel, but maybe they were trying to reduce maybe they're limited in their turbo sizing, and that they were trying to reduce the back pressure or something. I don't know. We couldn't really come up with a really good understanding of what they were trying to do with that. Brian, I have like endless amounts of information and testing up on the 706 head versus the 799. There's lots of direct back-to-back tests up on the channel for that. Toyota ran a single-sided turbo back in kart. They did? I thought that kart was pretty strict about that. I didn't think that they would allow people to be different. It wasn't a 4-cylinder? What's the max static compression ratio to recommend for a 464 valve at 20 pounds with the positive displacement blower on 93 pump gas? Is it a drag race car? Is it a daily driver? If it's a daily driver, I would have it like 9-1 or something. It just would give you a window for the 93. And why are you stuck on the 20-pound number for 93 octane? I'm always curious about that. Well, I'm going to run on 93 because I don't want to spend money to put. I don't have available E85, and I don't want to spend money to put race gas in it, which I fully understand. I have 93, but how do you decide on the 20-pound number? I have to have 20 pounds. I only have 93, and then I have this motor, but I got to have 20 pounds. Have you driven it at 20 pounds? Have you driven it at 15 or 10? I'm not putting you down. I'm just saying, I'm not knocking you. I'm just wondering, how did you derive it like at that number? Would it come in a conversation? Did you do the math and say, look, I need to make this kind of power and I'm only going to get there with 20 pounds? I'm just curious as to how you came across that. Any thoughts on how much power an unopened? Why does it have to be unopened? If you're going to try to make the most power that engine could make, you'd want to make some changes to it. It has stock head bolts, which are not great. It also has stock springs, which are not great. It has a tiny camshaft in it. I would put head studs in it. I would put springs in it, and I would put a camshaft in it. And then if you're trying to make power, then you can make a lot of power. Do bird catchers affect the reflected waves that extend past the throttle plates? The bird catchers are normally on top of a supercharger, so there's no reflected wave there. The reflected wave is only from the valve going up into the intake manifold into a common plenum, and on a big roots or twin screw or whatever supercharged steel that you would have like that you'd have a big bird catcher on, or bug catcher. I guess depending on what size it is, it's a bird or a bug. The intake manifold's under the blower, so the reflected wave has already happened there. And because those are so short, you're not really getting benefit from that. If you have a double overhead cam and your exhaust is the same lift and duration as the intake, is there a loss in power? Compared to what? Compared to having a dual pattern or going one way or the other? You'd have to test that on your exact application. That wouldn't be universal for all double overhead cams. I like the 20 pounds because that's how many digits I have. See, that's the perfect answer. So no back pressure for the dual 2 mufflers out back. I don't know what that means. 20 pounds is better than 19. That's right, Ark. You have the six-fingered man. I will go up to him and I will say, "You're killing my father." I have a twin turbo LSX. How would I determine when I need to switch from 93 to E85? You're there. If you have E85 available, you should, because you're going to make a lot more power. Best turbo for a daily driver Ford V10. How much power do you want to make? And then pick the turbo that will do that. For a V10, a GT45 is still a good choice for a V10. It's going to be a little bit, well, that's not a very big one, though. That's like a 6.8 liter or something. That'd be fine. That'd be good for 700 horsepower. And since that thing only makes like 300, you could double the power output. I just found my old copy of Super Chevy 2015, 3 ways to pick up power with a small block Chevy. Bypassing the exhaust through a wastegate wastes energy. Driving the turbo with fewer cylinders would save energy. That's what we thought it was a fuel mileage thing is the only thing that we could come up with, but we weren't sure. We never were able to talk to any of the team guys or the engineers. Does your new residence have a good place to run nearby? Like to just like this kind of running? If that's it, yeah. There's lots of places. What we do is take Milo up in the hills, and we either hike up in the hills or a lot of times I run the hills. I still haven't been able to run all the way up. I'm still working on that. So we're going to close out our poll. 76% saying yes with 166 votes. Would the injector position in the plenum above each cylinder provide adequate fuel distribution? So we'll end our poll there. Richard, would you lock out a distributor on a 550 horsepower small block? The power level has nothing to do with whether I would lock it out or not. The locking the distributor out, we do it a lot on the engine dyno because we're running from 3,000 RPM to 6,500 RPM or something. And usually a guy that has a carbureted combination with a distributor in it, and he has some sort of performance curve in his distributor, it's usually all in by 3,000 already. So he has all of the timing in. Normally, like if we look at an EFI car and going back now and knowing what I know now, I don't think that that's a good situation because I honestly think that when we run naturally aspirated like LS motors, we don't run, if we run 29 or 30 degrees at 6,000 or 6,500, wherever it makes peak power at, we don't run that at 3,000. It has less timing there. And so all you're doing by running all the timing at wide open throttle at every RPM is increasing your chance of detonation. So I wouldn't do that on any sort of street car I was driving around. You should put a curve in, and you should put a curve in that gives you the timing that you need in your situation. In an EFI car, it's really easy because you can go in and manipulate it. And at every different combination of load and RPM, you can put in whatever value you want. And so you can put in the timing value that makes the thing responsive, yet doesn't make it detonate. You can give it the best of everything. Running a lock distributor on the street is difficult because it makes it hard to start because it has full timing at idle. And it also doesn't give you the timing value that you would want. That being said, you can do it and people have done it and it will technically work. It's just not as good as if you didn't do that and you did it correctly. Race City, USA, Mooresville. I've been through Mooresville before. I went back to Maxton, which is in North Carolina. We drove all the way across to go run the Maxton Mile. So we were in your area. I mean, this was now years ago, but I have been to North Carolina before. if I'd been the editor of Super Chevy, I was never the editor. I was just a guy that gave them stories. And if you look now, which is really interesting, I find it interesting that if you look now on Super Chevy's Instagram posts and stuff, you'll see a lot of stuff that they're posting. And I think because I've been posting recently stuff that has done very well. And so they're posting a lot of stuff that are basically stories that I did. And I think my name is still in the story when you go to the story, but there's no mention of it on the post. They should say, hey, look, check out Richard Holdner's thing. Then it would help me too, but that's probably why they're not doing it. And I'm a little disappointed in that, having done stuff for those guys for 20 years. Have you ever tested an LS7 on the dyno? Not a factory one. I've built some, like I had that one LS7 or the 427 that was disappointing to me, and I've run lots of LS7 heads and stuff because we did the test with that, but not an original LS7 and not an LS7 454, if that's the other question. When am I coming back out to Ohio? Not for a while, not until the Omni's. Well, although I might take a trip out before the Omni's done. Have you seen Southeast Michigan dirt figure 8 racing? I don't think I have. Big Red Rocket Science. Figure 8 racing is awesome, though. I'm so if I can plug your channel, everybody go. If you want to go watch dirt figure 8 racing, which is you should. I mean, why wouldn't you? Go check out his channel. Bob, that might work. I'll tell them that I would cross promote with them. Thank you. Think about putting together an LS out of an LS7 block. I ran Brian Tooley's 454, started out as an LS7 block, and that thing made 700, so it did really good. That video is up. You can take a look at that. Only if the figure 8s use buses or the chain races where the cars are chained together. I like that too. Because they're chained together. And trailers are another good one. I liked watching the big rig road racing too. As your side hustle as a roller derby promoter, that would be how awesome would that be? It's easy to get a used late model cup engine out here. That'd be interesting. They have a couple of those at West Tech. The guys from Lucas Oil have brought in a few of those, and they've run them, and they are cool. I mean, I just like looking at the attention to detail in some of those things. I mean, everything's like scalped out and lightened. I mean, they're just like perfection. Matt, have you ever thought of doing an LT head to an LS block? You can take a look at Brian Tooley Racing's. If you don't follow them, you should follow them on Instagram and on Facebook, because they did that recently. They put a LT head, an LT1 head on an LS3 block. But the problem is that you have to do a lot to make that happen. And quite frankly, an LS3 head's already really pretty good. But they did ported versions, I think, of both, and maybe in stock versions of both. But in order to do that, like swapping the head, because it kind of bolts on, is okay, but it requires a custom cam, a different intake manifold, all of the rocker assemblies. You have to have a different header. So it's not just like you're swapping a head. It's a lot more involved. Dirt 8s and big rig racing. I know. Yeah, you got to see if you do a search for it, there's got to be, I know that there's a bunch of YouTube stuff up on it. And the problem is when they get together or when they crash, like the guardrails and the safety equipment were designed for cars and not for these trucks. So it's crazy. boost the cup engine. None of the cup engines are mine, and one of them that they had there is not very powerful. The other one is like in the, I think, mid 8s or something. No bushes are changed, but the cars weigh 6,000 pounds with a defensive weld on steel. That's good. I bet that I would kind of like to see the cage structures in those, because that's got to be pretty awesome too, because you want the guys to be safe. Casey, I've never, and yours will be the last question, your last comment. I've never seen a chicken race like that we were talking about with a relay deal, but we did that when I ran with the Shelby Club out at Willow Springs. I brought my 5-liter Mustang with nitrous on it, which was the only way that I was able to keep up with. It had good suspension on it. My car had good suspension, and I actually put slicks on it. I just put slicks on the stock wheels, so they kind of fit. But they were, what were the slicks? Goodyear Sports Car Specials, I think, back in the day is what we ran. And so I had slicks on it. I had shocks and springs and bars and all that stuff. So it handled pretty well. And I had I think it was only a 75 shot on there at the time. But we had a relay race. So there was a total of 5 cars in each team. And I think that there were 4 or 5 teams. And so they started the race, and the guys had to race. We had to each race like 5 laps. And then we would come in, and our guy would come in at the end of the pit, and then we'd have a runner that he would touch that car when he would stop, and then he would run over and then touch the car, and then that car could then start. So I said, well, right off the bat, we're getting a young guy to do the run. And I said, you better pay, because it's a fairly long pit lane that he has to run. I said, so pace yourself so that you make all these like in an equal amount of time, but go fast. Because a lot of them had older guys on the team. I'm like, dude, you're going to be able to smoke those guys. So we probably picked up 5 or 6 seconds just from our runner choice. But we went out, and I was with 4 other like GT350s. So they were all 65 and 66 GT350s. 2 of them were like converted GT350R cars. They weren't original ones, but they were done to look like that. The other ones, one of them was a Hertz rental car, and then the other one was like a red and white 66 GT350. And so we went out, and we had some good drivers. We were going around really good. And they're like, okay, we want you on that. We want you on the team. So we saw what you're packing. So we want you to do well, because this car would go out and run. You know, it already handled as well as a lot of these cars. And I knew how to get around Willow Springs fairly well. And then with the nitrous, I had, we had power for the straightaway. So it worked out really well. So our team ended up winning. So it was awesome. I like those kinds of relay races. Cam motion makes a cam. You just need to swap the dowels from the head from the top to the bottom, and the rockers and the intake manifold and the headers. Yeah, the big trucks that's a good point. The big trucks weigh a lot. And that was the problem, is that you see some of those. And if you look on YouTube, they're there. If you see some of these crashes, I mean, they come in, you know what a K-rail is. You set up K-rails for safety. We raced with those like at the Long Beach Grand Prix, and I ran a street course at Dallas. It's all the same thing. They set up the K-rails, and so that and fences and barriers so that people don't go on them. But if a car hits that, it goes up pretty high and gets crazy. But when the trucks hit it, it just destroys the K-rail. It's pretty cool stuff. And on that note, it's time to get going. Thank you guys all for showing up. I need to get on the road. I need to go down and build stuff. Build it and boost will come. That should be a shirt. Thank you guys all for showing up. I'll see you all tomorrow. And